So in this video, we are talking about functions, relations, and graphs. Now, the definition of a function is that a function is a set of ordered pairs, so x, y as a coordinate, in which no two ordered pairs have the same x coordinate. Now, this last bit we'll talk about in a moment when we talk about relations. But with our functions, basically it's the graphs that we've been looking at, and the graphs are made up of different types of ordered pairs that satisfy the rule. So to describe a function, we can talk about its domain and range. Now, a domain is the set of all possible x coordinates that the function can exist in. Its range is the set of all possible y coordinates. Now, these are useful because they allow us to understand how the function behaves and where on the Cartesian plane it exists. So in this first example, it's saying to write down the domain and range of the functions whose graphs are sketched below. Now, this one on the left, we can see that this is a parabola. It's a concave down parabola. So for the domain, this parabola, it's just going to continue going down. Now, it doesn't look sort of super steep, but basically this function is just going to continue in this direction and in this direction. So this function can actually take up all real values of x because it's just going to continue towards positive infinity in the x direction and negative infinity in the x direction as well. So when we talk about the domain, we are just going to say it's all real x. The range, however, we can see that the maximum turning point of the function has a y coordinate of 4. So it's not going to exist above this positive 4 here, but everywhere below it, because it just continues infinitely down, it will exist. So for the range, we can say that it is the inequality y is less than or equal to 4. Now, it's important to specify that it is less than or equal to because it can take this value of 4. Now, for this next one here, we have a cubic function, but we can see that the domain, because the function goes and basically stops here at positive 2 in the x and stops here at negative 2. That's what these points show. If it had the arrows, it would continue going in these directions, but it actually stops from negative 2 and then goes up to positive 2. So the domain is going to be in between, x is going to be in between negative 2 and positive 2. But it can take on these values because the circle is closed. If it was an open one, then this would be an inequality where it can't be equal to. It'll be discontinuous at that point. It would stop. So the range, it goes from negative 8 to positive 8. So the inequality that describes this is that y is between negative 8 and positive 8. And once again, it can exist at these points. So we have to do less than or equal to for these, for our inequalities. Now, one more thing we're going to talk about is what we call the natural domain. So if no restriction is given, the domain is all x values that can validly be substituted into the equation. So where this comes up is for certain types of functions like these ones below. Now, it's saying find the natural domain of each function. Now, in order to do this, we need to consider why a number cannot be substituted into an equation. So where an x value may not exist. So there's a couple of things that we need to remember, particularly when we deal with these types of functions. So this first one, you guys may remember this is a reciprocal function or a hyperbola. So for this one, we have to remember that because the x is on the denominator, there is one value that can't be on the denominator, and that's an x value that will make 0 on the denominator because we know that we can't divide by 0. So to decide the natural domain, we know that x minus 2 can't be 0 because the number on the denominator cannot be 0. Therefore, rearranging this equation, x cannot equal to 2. Now, for the one on the right here, part B, we can't take square roots of negative numbers. So the number under here, under the square root sign, can't be negative. So we know that x minus 2, this thing under our root, has to be greater than or equal to 0. Because remember, we can take the square root of 0, but we can't take the square root of anything less than 0. So rearranging this inequality, we get that x is greater than or equal to 2. So this is the natural domain of each of these functions. Next, we're going to talk about relations. Now, a relation is any set of ordered pairs, and unlike the function, it may have 2 or more points with the same x coordinate. Now, down here, it's saying in each part, show that the relation is not a function by writing down 2 ordered pairs on the graph with the same x coordinate. Illustrate this by connecting the 2 points by a vertical line. Now, this vertical line bit, we're going to talk about in just a moment, because this is a really quick and easy way to determine whether a relation is a function, or whether we have an actual function here, or if it's just a relation. Now, you can see that both of these ones here, we have the graph of a circle on the left. Now, with this one, we can clearly see that there are points here which have the same x coordinate. It actually goes all the way through here. So up here, down here, here, there, basically everywhere. But these two are the easiest ones to think of. So the points 0, 5 and 0, -5 on the graph have the same x coordinate of x equals 0. So we're going to draw in our 2 points here. So this is 0, 5, and this is 0, -5. And it's saying connect the 2 points by a vertical line. So this vertical line passes through these 2 points. This is just to show that that same x coordinate produces 2 different y coordinates. Now, this vertical line, x equals 0, meets the graph at 0, 5, 0, -5. So relations like functions have a domain and range, so we can describe this relation with a domain and range also. Now, the domain is going to be in between -5 and +5. And remember, we have to write less than or equal to because it can take up these x coordinates. And the range will be from -5 to +5. Now, moving on to the next one, we're going to look at 2 points that have the same x coordinate. Now, I can see on this graph these two. So I have the coordinate of 1, 1. That has a particular x coordinate of 1, but this coordinate 1, -1, this shares the same x coordinate, and we can show this by drawing our dotted line. So we can say that the vertical line meets the graph, this vertical line x equals 1, meets the graph at the coordinates 1, -1, and 1, +1. Now, the domain of this graph, because we can see that it continues infinitely in these 2 directions here. It starts at 0, the x coordinate of 0, and it's going to take up all of these x values that are 0 or more. So the domain, we can say, is x is greater than or equal to 0. And the range is going to be all real y. Because this is just going to continue down into all of the y values that are less than 0, or the negative y values, just infinitely, and this one infinitely here. Those arrows on the end of this relation just show us that it goes infinitely in these directions. Now, what we've touched on by drawing this vertical line is something called the vertical line test. So this is a way to tell immediately whether something is a function or not. Now, these 2 graphs, they fail the vertical line test. So we can draw at least one vertical line through, and it passes through the graph more than once. So this line here passes through our relation more than once. We have a few others, but all we need is at least one. Anytime it's one time or more, then the relation is not a function. So in both of these cases, these are not functions. These ones, however, if we draw a line through, we can see whether it's here or here or here or here, it doesn't pass it more than once. So we need, like we had down here, it passes it more than once. So Therefore, it's a relation. Here it's a function. Every single line we draw through just passes it once. Same thing happens here. Draw a line through, draw a line through, draw a line through. Anywhere I draw my vertical line, it will only pass through this graph once, meaning that it is a function. This is a really quick way to distinguish between the two. The vertical line test gives us a good way to do that. But that brings us to the end of the video. Thank you so much for watching, and I'll see you next time.